Alright, welcome everyone to another video of physics. This one's going to be on mechanical energy. I really like talking about mechanical energy. It's a very important topic in physics. What I've got for you in this video of physics is 2 example problems. And then in the video physics assignment you'll have 3 questions. So I hope to keep it short. We're going to start right away and just get into it. So what is mechanical energy? Mechanical energy is the sum of the potential and kinetic energies. If you look at its formula and how you find it, you simply just take the potential energy of the object and add it to its kinetic energy. You add them up. Remember that potential energy, if you haven't watched the video on that, you find it by taking the mass, timesing it by acceleration due to gravity, and timesing it by the height. Kinetic energy, you find it by taking 1/2 the mass of the object times its velocity squared. And so in the end, you just simply add those 2 things together and you get mechanical energy for the object. A lot of times mechanical energy will be called the total energy for the object. And so let's go through a couple of practice problems to get a sense of mechanical energy. Practice problem number 1, it says, using the pendulum below, answer the following questions. And we've seen this diagram before many times in class and even on the previous video physics on kinetic and potential energy. But it says on A, what kind of energy is at point A? And it looks like to me point A and C on this pendulum are at its highest point. And at its highest point, we've talked about this a lot, the velocity at its highest point is equal to 0. And so it would not have any kinetic energy. All of the energy at point A is potential energy. It's at its highest point. And so we can go ahead and put that on for C as well. Because over on this side the velocity will be equal to 0, so it doesn't have any kinetic. All of it would be potential energy. Now when this pendulum swings back down, it looks like to me that B is at its lowest height, or a height of 0. And so at point B, because it has a height equal to 0, it will not have any potential energy. It will all be kinetic energy. And this is at point B where the velocity of this pendulum will be at its max. Okay, and that's going to have, it's be going the fastest at point B. And so what is the energy at point A? Well, it's all potential. Point B, it's all kinetic energy. At point C, again, it's all potential energy. But a very important question I wanted to go over with you in this video of physics was part D. It says, draw an energy versus position graph and include the mechanical energy, kinetic energy, and potential energy. And so let's go through one of those examples on how to do this. If you draw a y-axis here, let me see if I can do it straight, and an x-axis, and say the y-axis is energy. The energy of this pendulum bob as it swings back and forth. And on the x-axis, we're going to have that be its position. Okay, and let me switch colors here. For position A, we'll start at position A, then we'll go to position B, and then we'll finish at position C. And so we're going to graph its, let's start by graphing its potential energy first. At point A and point C is where the potential energy is going to be its max. So if I say, maybe right here is its max energy at A, potential energy is going to be its max. At B, potential energy is going to be 0. And so you're going to see this kind of parabola-like shape as it comes down to position B, and then it goes back up to its max at position C. And so that, let me make a key for you. The green line represents potential energy. Now I'm going to switch colors and let's graph kinetic energy in red. And so let me make this on the key. Kinetic energy will be in red. And it looks like to me, since the velocity is 0, it starts out with 0 kinetic energy at A. At B, its kinetic energy is going to be its max. That's where it's going to be moving the fastest. So it's going to look something like this. And then at position C, again, it goes back to a kinetic energy of 0. And so it's going to look kind of like its inverse, or a mirror image of the other one, where it comes up here and at position B it's at its highest, and then it comes back down to 0 at position C. Okay, and here's a good way of kind of looking at mechanical energy. I'll do that in blue, and hopefully you can see that. So I'm going to graph mechanical energy in blue. Now remember, mechanical energy is equal to potential energy plus kinetic energy. So we add them together. Now if we look at this, all of it at position A is potential. And so we don't know the number is, but kinetic was 0. So all of that energy was potential. And so if we add that together, its mechanical energy would be right where that position is. And the thing about mechanical energy we're going to talk a lot about in this video is that once you find mechanical energy, it never changes throughout that object's path or its motion. And so we can just fill that in. And if you look here, if you say you were in between positions, so we're talking about when the pendulum is right here, half of it's going to be potential and half of its energy will be kinetic. And if you add them together, it's still going to equal what it did before. And that's the thing about mechanical energy. You simply just add potential and kinetic, and then it's done. So that is an energy and position graph for that pendulum, and hopefully that makes sense. So let's go to another practice problem. I got this last one for you, and then we'll be done. This is a diagram of a roller coaster. So it says use the diagram of the roller coaster below to fill in the table. So we've got to come up with answers for all of these blanks in this table down here. And here's the roller coaster. It says has the mass of 800 kilograms, so we know its mass. And then it says assume the roller coaster is stopped at position at point A. And so at point A, its velocity is equal to 0. And that's all we know so far. We do know it has heights on this diagram of the roller coaster, and we know that it starts with a velocity of 0. So let's start at position A. I always think the easiest place to start is finding potential energy. So at position A, let's find its potential energy. And that's equal to mgh. So its mass was 800. Okay. G is 9.8. And its height at position A is 30 meters. So 30 goes there. So let me do that calculation on my calculator. So 800 times 9.8 times 30, and I'm getting it's a very large number. So potential energy. Let me see if I can get a better color for this. Yeah, maybe red will work. 235,000 and 200. And of course this is going to be in joules. I'll for this, because there's not much space, I'm not going to write joules every time, but all of these energy values are going to be given in joules. And so at position A, because its velocity was 0, it's not going to have any kinetic energy. So its kinetic energy will be 0. And that means its mechanical energy, again, mechanical energy is equal to potential energy plus kinetic energy. And so if we add these two together, we should get mechanical energy. So it's 235,200. And that's an important point. For this roller coaster, anywhere along its path on this track, its mechanical energy is going to be the same. So I can go ahead and fill in the rest of this, 235,200 at B and also at C. Okay. So once you find mechanical energy, you've got it for its whole path along this track. All right, so let's go to position B. If we look at position B real fast, it's got some potential energy because it's got a height, But as you imagine, as this roller coaster comes down, it's going to pick up a lot of speed. So it's going to have a lot of kinetic energy as well. So in part B, it's got kinetic as well as potential. But I always think that the easiest place to start is potential energy. So let's find its potential energy right here. We take its mass, which was 800, times it by 9.8, and times it by its height, which is 10. Okay, and so I've got it on my calculator. 800 times 9.8 times 10. And so it comes up with a value of 78,400 joules. So I'm going to fill that in for potential energy at point B, which would be 78,000. Whoops, I switched colors. Go back to red. 78,400. Okay, and there's a couple of ways to think of this, but I think to figure out its kinetic energy, it never told us how fast it was going, so we can't use, for this point, kinetic energy is equal to 1/2 mv squared, because we don't know its kinetic energy and we don't know its velocity just yet. We can figure it out, and here's how you do that. So because we know mechanical energy is equal to potential energy plus kinetics, let's just plug it in here. Mechanical energy was 235,200, and that's equal to its potential, which was 78,400, 78,400 plus its kinetic energy. And so we can solve for kinetic energy using this equation. We simply subtract 78,400 from each side. So 235,200 subtract 78,400 will give us our answer. And so kinetic energy at point B is going to be 156,800. And so if you added these two together, they should add up to our mechanical energy. Okay, and so we are forgetting to figure out the velocity here. At point A, its velocity was 0. Now let's figure out what its velocity will be at point B. Okay, we want to know what its velocity is. So I'm going to come back down here and work this problem. At point B, we know that kinetic energy was 156,800. And we know kinetic energy is equal to 1/2. The object's mass was 800. And we're trying to figure out its velocity. We don't know it yet, but we'll just put it as v. And so let's solve this equation real fast. 1/2 of 800 is 400. So 156,800 is equal to 400 v squared. Divide both sides by 400. Okay, so divide by 400, I get 392. So v squared is equal to 392. To get rid of the square, we take the square root of both sides. So the square root of 392 is 17.8. Or no, sorry, that's 19.8. So 19, so velocity is equal to 19.8 meters per second. And so let's put that in our table. So that'll be 19.8. And of course, velocity is given in meters per second. And all of these are going to be given in joules. Okay. So 19.8 is how fast it would be going at point B. Now we've just got C left and then we're finished. It's going to go back up this hill, so it's going to use a little bit of its speed to get a little bit more height. Again, I think the easiest place to start, and really the only place we can start at this point, is figuring out its potential energy at point C. So potential energy is equal to its mass, which is 800, times 9.8, times the height at point C, it's 25 meters. So 25. Okay, 800 times 9.8 times 25. My calculator is telling me it's 196,000. 196,000. So I'm going to put that in for potential energy. 196,000 joules. Okay, and so if kinetic energy plus potential energy equals mechanical energy, we can just simply subtract the potential energy from the mechanical energy and we'll figure out its kinetic. So we take 235,200 and subtract 196,000. That should tell me my kinetic energy. And my calculator tells me it's 39,200. Okay. And now everything's finished except for we need to figure out what its velocity will be at point C. We know its kinetic energy is 39,200. 39,200. Let's set that equal to the kinetic energy formula, 1/2 times the mass, 800, times velocity squared. Okay, again, half of 800 is 400. So let me come back up here and continue this up here. So 39,200 is equal to 400 v squared. Okay, we divide both sides by 400. So 39,200 divided by 400. My calculator is telling me that that is equal to 98. So I'm getting tight on space here, but 98 is equal to v squared. Take the square root of both sides, so the square root of 98 should tell us what the velocity will be, and it's 9.9. So go back to red, and the velocity at point C will be 9.9 meters per second. And everything seems to make sense. As it goes down, it's going to have its greatest velocity at point B, because that's the lowest point. And then as it climbs back up, that velocity is going to decrease. But we'll get more height, so we get more potential energy. And so that's one example of a roller coaster and how to figure out its potential and kinetic and mechanical energies. So hopefully that helps. I've got a video physics assignment for you. So following, there will be 4 questions I would like you to answer on a piece of paper. And you'll turn these in for points. As always, if you have troubles with it, come by, stop by anytime. I'll help you out. And honestly, hopefully throughout the example problems, you'll be able to figure those out. But good luck, as always.